episode 10 of the World of FPGA podcast. SoC, all in long, system-on-chip are highly integrated electronic components. In today's episode, we will discuss the idea behind SoCs. Welcome to the World of FPGA podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. In the last episodes, we talked about FPGA devices. Now, we want to look at higher integrated components, and first, we have a look on basic definition of SoCs. Wikipedia says here, a system on chip is an integrated circuit that integrates most or all components of a computer or other electronic systems. So SoCs have many different functions in one package. Sometimes could memory soldered on the top of the processor or on the SoC just to save a lot of space. Basically, SoCs are different chips or different functions combined on one silicon just to save space, to save routing and so on. But what are SoC in the world of FPGAs? Well, there are different components from many different manufacturers. And in the next episodes, I just will list some of them here in this podcast. So you will hear more about the manufacturers and their devices, devices of SoCs. And most common is that we have a combination of an FPGA core and a processor core. This processor is often one or many ARM cores of different speed, of different power, and it is also common to add other functions to this SoC, to the FPGA, such as a graphic core, memory, or something like that. And what is the idea of such integrated systems? Well, in not integrated systems, we have, for example, our FPGA as our main part of the whole circuit. We have coprocessors, we have volatile and flash memory, we have a memory controller, we have different interfaces, we have maybe just bus decoders and clock generators and clock distribution and many more components. And a lot of copper traces we need to connect all these parts of our circuit. And also we have to choose the correct components to do the correct layout, to have the correct length of PCB traces and so on. And it will cost a lot of PCB space and also a lot of time just to develop such a system and also to debug such a system. We will need time for development and for debugging and to find the correct components. And when we use a system on chip, it saves a lot of PCB space. And we need less components. The parts in an SoC are working perfectly together. Well, sometimes we need to choose some memory here. Also, we need some volatile memory like DRAM, and we also need flash memory. Yeah, and also PCB layout is needed, of course, but it's more simpler as with the SoC as if we would have all the dedicated parts on our PCB. On the development side, most manufacturers deliver us a development suite. And the suite is used for both for the FPGA side and also for the processor side. And we will get a toolchain for generating a flash image which has all the all the binaries, all the bit streams we need for our SoC in one part that the FPGA can boot automatically. And for IP cores we are using on the FPGA side, for example, we have a component with an XC interface which we want to control from our processor side. There are commonly drivers are generated, for example, in C or C++ or these languages. And this driver can now use directly on the processor side to run our application and to control the FPGA side from the processor side. And if we have a look on the processor side here, most time we have, or not most time, on one hand we can have a bare metal application, so a program that runs without an operating system, just doing all the controlling stuff of the FPGA and of the interfaces and so on, maybe just doing some calculations. And the other variant we can have here is that our processor running under an operating system, especially embedded Linux is often used in such SoCs, and the manufacturer most time delivers a working tool chain to generate an embedded Linux image. And in the next episodes we will talk about the manufacturers and their parts you can buy from them with all the pros and cons. There maybe will appear. In another episode we will talk about the workflow, because it's we have two components we have to combine in one big workflow, and this is another episode. We will talk about this topic and also about embedded systems. I will create an own episode just to talk about embedded systems. In this case, I can give a hint. We will talk about embedded Linux. Well, that's all for today's episode, just as an entry point for this topic for SoCs. And I hope it was interesting for you. You can find further information on the website world-fpga.com/WFP010. If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye, here next time, your David Kirchner.